Guys, in this video we are going to solve one more recursion problem that is based on tree. Okay, so let's try to understand the problem statement first. So you have been given an integer n. This n is nothing but number of nodes. Okay, number of nodes. So assume that you have been given a number of nodes and you have to return all possible full binary tree with this n nodes. Okay, but what is full binary tree? Let's try to understand this. A full binary tree is a tree where each node has exactly 0 or 2 nodes. Okay, can be a full binary tree? As per our definition, it has 0 node. Okay, so this is a full binary tree. Can be a full binary tree? No, right? Because as per our definition, it says that it should have 0 or 2 nodes, but it has 1 node. So this is not a binary tree, full binary tree. Okay, what about this? This is full binary tree because this node have 2 children and this one have 0 and this one also have 0. So this is a full binary tree. Okay, so you have been given n and you have to return a list of all possible full binary tree with n nodes. Okay, so for example, n is equal to 7. For n is equal to 7, these are the possible binary tree you can generate. Okay, what you have to do is you have to, in one list, you have to return all the root nodes of these generated binary tree. Okay, I hope you know that if we get the root of any binary tree or any tree, we can travel throughout the node, correct? So you have to return the root of those generated binary tree. So let's move to the solution part and try to build the solution step by step using our framework. So in our framework, the first step was to find out the base case. Okay, find out base case. So let's try to find out the base case for n is equal to 7. We have been given 7 nodes and we have to find out all the possible full binary tree for this. Okay, so let's try to find out the base case for this first, then we will move to the solution part. But first step is to find out the base case. Okay, can I say that this n is equal to 7 is heavily depend on n is equal to 5? You will ask how. Okay, so what are the possible solution for n is equal to 5? I can say that this can be one possible full binary tree for n is equal to 5. I can say that this can be one possible solution for n is equal to 5. Other than that, you cannot generate any solution when given number of nodes is 5. One thing you have to notice that you cannot generate a full binary tree when n is even. Okay, you cannot generate. Okay, because if here 5, if I have been given as 6, you will be left with one node. If you place anywhere, here or here, if you place anywhere, this full binary tree will become unbalanced. Okay, because at some point it has some one extra node. Okay, and full binary tree says that it should not contain one node, it should have either 0 or 2. Okay, so you cannot generate a full binary tree when the given number of nodes are even. Fine. Okay, n is equal to 5, we have these two solutions. Okay, can I generate solution for n is equal to 7? How? For n is equal to 7, I have now from here to here I have 2 extra nodes only. Okay, for n is equal to, from n is equal to 5 to n is equal to 7, I have 2 extra nodes. Can I say that if I place these 2 extra nodes at every point where the node has 0 children, can I say like that? Okay, let's try to do that. Okay, this node has 0 children, so can I place these 2 extra node here and I can say that this is one possible solution. Okay, let's try to count 1 2 3 4 5 6 7. Yes, this can be my one solution, correct? Another solution can be, this was solution for n is equal to 5. we have place here, now we will place here. Okay, fine. This can be also my one possible solution, correct? I can say that, can I place at this point? If I place, this can be also one possible solution, because given number of nodes are 7 and all the nodes had 2 children and this last level has 0 children. Okay, so this satisfy the full binary tree condition, so I can say that this tree is a full binary tree. Okay, other than that I cannot find, I am unable to find any node which has 0 children. Only these 3 were there, so I have placed my extra 2 nodes at those points and I have generated a full binary tree for n is equal to 7. Okay, what about this part? Till now I have got full binary tree for this part only, right? I have another solution for, I also have another solution for n is equal to 5. Okay, so let's try to generate for this part also. Okay, these are, I can see that these are the nodes which have 0 nodes, correct? So I will place my extra 2 node at those 2 points. Okay, first I will place here. Okay, so this is also my one full binary tree for n is equal to 7. Now I will place at this point. Okay, I will place at this point. Okay, another solution can be, I will place at this point. Okay, fine. So these are the possible solution for n is equal to 7 for this part. First part was my this one. Okay, let me write here. First part was this one, and for this part I have generated 1 2 3, and for this part I have generated 1 2 3, so total 6 full binary tree I have generated. But one thing is that, one thing here we have to notice that this one and this one are same. Okay, so we have to tackle that problem, this problem also, that we should not generate a duplicate full binary tree. Okay, so if we are generating that, we have to remove that. Okay, so let me remove this, because this tree is already generated. We have to give the all possible, not duplicate ones, we have to give the all possible full binary tree. Okay, so how many binary tree we have generated? That is 1 2 3 4 and 5. So we have generated 5 binary tree, full binary tree for n is equal to 7. Okay, what this says that if n is equal to 7 depend on n is equal to 5, then I can say that it should heavily depend on n is equal to 3. Okay, so same thing we can analyze for n is equal to 3 also. Okay, so what is the possible full binary tree for n is equal to 3? I can say that there is only one possibility, that is this one. There is no other way you can generate a full binary tree. Okay, so I can see 2 nodes which have 0 child. Okay, so I will place my 2 extra node at those 2 points and generate a solution for n is equal to 5. Fine. So for n is equal to 5, I got 2 solution, correct? There is no other way you can generate a solution. Okay, so I can say that n is equal to 5 is heavily depend on n is equal to 3. Can I say that for n is equal to 3 is heavily depend on n is equal to 1? Let's see how. Okay, can I say this is a full binary tree? Yes, number of nodes are odd. Yes, first criteria fulfilled. Second criteria was it should contain either 0 or 2 child. It has 0 child, so second criteria also fulfilled. So this is a full binary tree. Okay, and I can see that this tree is a, this tree has 0 child. So can I place for n is equal to 3, can I place my 2 extra node at this point, and I can say that I have generated all the possible full binary tree for n is equal to 3. I have used the solution for n is equal to 1 and I have generated the solution for n is equal to 3. So smallest problem occur for n is equal to 7, that is n is equal to 1. If I know the solution for n is equal to 1, I can generate a solution for n is equal to 3. Once I generate the solution for all the possible solution for n is equal to 3, I will place my extra 2 node at all the nodes which has 0 child, and I will generate all the possible way for n is equal to 5. The same thing I can do for n is equal to 7. I will place my extra 2 node at all the possible nodes which have 0 child, and I will generate the solution for n is equal to 7. Okay, so from this analysis we got that our base case, that is n is equal to 1. Okay, Now let's move to the second point, second step, that is draw a diagram. Okay, so this was the only my diagram, but we will understand, we'll try to understand one more time. So let's try to build a diagram for n is equal to 7 again. Okay, can I say that n is equal to 7 is heavily depend on n is equal to 5? Once I get the answer for n is equal to 5, so there are two solutions for n is equal to 5. First is this one and second is this one. Okay, so at all the nodes which are 0 children, if I place my extra two nodes, okay, for n is equal to 7, my extra two nodes for all the nodes which has 0 children, I can make a solution for n is equal to 7. Correct? What I'm trying to tell is these are the nodes which has 0 children. If I place my extra two nodes at these 3 points, I can make a 3 solution for n is equal to 7. Correct? What are those solutions? I can place my extra two nodes here, I can place my extra two nodes here, I can place my extra two nodes here. So these are my possible solution, and if I have a solution for n is equal to 5, then only I can generate this. Okay, now we have another solution for n is equal to 5, and these are the empty, or I can say the node which has 0 nodes. Okay, so I will place my two extra node at this point and I will generate all the possible binary tree for n is equal to 7. Correct? I hope you understand this. Okay, so we will try to finish our next step also, that is build a relation. Okay, build a relation. So try to understand this. The relation is pretty simple. If you get the solution for n is equal to 5, if you get this solution for n is equal to 5, what n is equal to 7 can do, he can place his extra two node at all the place which at all the nodes which have 0 children. Okay, using this he can generate all the possible full binary tree. Okay, so relation is pretty simple. Get the solution from your sub problem and place your two extra node in sub problem, which the node which has 0 nodes. Okay, so I hope you understand these two things, diamond relation also. Okay, let's move to the another part, that is final part, that is code it. So let's try to code it. Okay, so let's move to the coding part. I have divided my coding part into 3 sections. In first section we are going to generate all possible ways. Okay, all possible ways. In second part we are going to clone this, clone the generated full binary tree. Okay, in third part, okay, before saving that full binary tree, we need to check is this unique or not, unique or not. If yes, then save, else ignore. Okay, so what this means, for n is equal to 5 we got these two solution, right? For n is equal to 5 we got these two solution. Now if I want to make n is equal to 7, I have a choice. In this part I can place these two extra node here, and in this part I can place these two extra node here. Okay, so this both in structure wise same, right? Correct. So I want only one of them. I want all the unique possible way of full binary, but these are, but at some point of time it will generate duplicates, so we need to ignore those duplicates. Okay, so what I'm going to do is at every point of time I will check in my list, in my, I will be making a list where I will storing all the root node of my generated full binary tree. I will check with those generated tree that if that my newly generated tree is similar to any existing full binary tree. If it is there, I will ignore. If it is there, I will ignore. Else I will add into my tree. Okay. Now another thing, you have a question that why we need cloning. Okay. So I want to tell you that whatever the changes we are going to do, we are going to do in a same tree. Okay. We will be adding two node here. Then after saving, we will be removing this two node and we will be adding another two node here. Then again we will be removing this two node and we will be adding another two node here, and we will remove this. So before removing, we need to clone that generated full binary tree. Okay. So because we are doing the changes in the same tree, reason we need to clone our generated full binary tree. Okay. So let's try to code it. I'm not going to code here. I'm directly going to code in the ID part by part.
Okay. So let's move to the ID and code it.
Prepare template for my tree. So I made a three variable, which is value, left and right node. Okay. So I have already prepared template for my tree. So my tree contains a value, a left child and a right child. Okay. Here I have wrote three constructor, which is used to initialize my all these three value. Okay. So let's try to code our utility method first. We have discussed that we have two utility method. First one is a clone method and another is to find out are trees similar or not. As of now, we are not going to focus that how these two methods work internally. Okay, these two methods can be a one separate recursion problem. Okay, and definitely in future I will bring video on this. But as of now, we believe that my clone method is going to give me a clone of my tree, and all tree similar is going to return boolean value. If I pass two different tree, it will check whether these three are similar or not. Okay, so we'll simply believe that this method is going to work. We are not going to deep down into these two methods. Okay, so let's write our first method, that is clone. So public static, and it is going to return a root of the clone tree. Okay, so clone, it is going to take one variable, that is I will write that as a node. Fine, I will check if node is equal to null, then simply we need to return null. Okay, else what I need to do is I will make a new tree node equal tree node. Fine, and what value of this tree node, in our lead code question it says that the value of the all the nodes should be 0, but here to debug and to we have to display also. So I'm going to put the unique value so that we can identify all the nodes differently. Okay, so I will give node dot value itself, whatever the value of the node is, I will put that value itself. Okay, now what I'm going to do is new node dot left is equal to, I will call my clone method by passing node dot left. The same thing I will do for right also. I will make a to call. I will ask clone method to clone the left part, and I will ask to clone the right part. Whatever the answer I will get in my new node, I will add that to the left part and the right part. Okay, at last I'm going to return whatever the new node root is. Fine, so this is how my clone method looks. Now let's try to code our next method, that is r tree similar. Okay, r tree similar, and it is going to take two tree. Okay, so tree node tree 1, tree node tree 2. Okay, now I will check if tree 1 is equal to null and tree 2 is equal to null, then I will assume that my both tree till now it's same, so I will return true. Okay, I will return true. If this condition is not satisfied, then I will check is tree 1 is not equal to null or tree 2 is not equal to null. That means if any one of them is not equal to null and one of them is null, okay, one of them is null, then we are going to return false, because this says that my both tree are not same in structure. Okay, if any of this condition will not satisfy, then what I'm going to do is I will call left, I will make one variable left result, and I will call r similar, and I will pass tree node. I will order my rt similar function to find out in the left part. Okay, so I will pass t1 dot left and t2 dot left. Okay, the same thing I need to do for right also, for right result, and here we are going to do right. Okay, fine. Now we need to return. Okay, what this means, this means we are going to return and of this two variable. Okay, if one of them is false, then both result will be false. If one of them is true and other is false, then also we are going to return false. That means structure is not same. If both are true, then only we are going to return a true. That means my both tree are same. Okay, so this is how my rt similar function looks. So let's move to the another utility method that we are going to write, that is display. Okay, so I have already prepared a display tree method which is going to take a node, and I will check if it is null, then I will simply return. Else what I'm going to do is I'm going to display in this manner: root and its right node value, and its left node value. Okay, and this is root value. Okay, so I'm going to display something like this. For example, if root has value as 1, left have value like 2, and right have value like 3. So this is how I'm going to display. So for that only I'm preparing a string. Like, I will add the node value first, then if I check if it has left and it is not equal to null, then I will add that value in that string. Else if it's null, then I will add null to the left part. The same thing I'm going to do for the right part as well. I will check if node contain right, then I will add that right value, else I will add null. Okay, then I will print myself, and I will order my display 3 method to print result for the left part and result for the right part. Okay, so I hope you understand these three utility method. Now let's move to the main part, that is finding out are they similar or not. So let's code it quickly. So let's move to the interesting part, that is to find out all possible way to generate a full binary tree. Okay, so what was our logic? So our logic is pretty simple: get the result from sub problem. Let for n is equal to 7, I will get result from n is equal to 5. Okay, so these are the result we used to get for n is equal to 5. What I'm going to do is I will find all the node which has 0 children, and I will place my 2 extra node as those places. Okay, so this was my approach, correct? This was my approach. So let's try to code it, this logic. Okay, so what I'm going to do is I'm going to make one function, and it is going to return nothing, so void, and I will name that function, that is place it. It is responsible to place my 2 extra node at the node which has 0 children. Okay, so it is going to take 3 argument. First is root. I'm not going to change this root value. Okay, another argument it is going to take, that is node. So I'm going to, in a recursion, I'm going to change this node value every time, and one more value I'm going to pass a counter. This is basically to place a unique value in every node, so that we can identify every node uniquely. Okay, so this is for counter. Fine. So when I come to this function, I will check that my node is not equal to null. Sorry, if my node is equal to null, then we'll simply return null, or we can simply return from there. Okay, else if it is not equal to null, then what I'm going to do is I will check node dot left equal to null, and node dot right equal to null. This denotes that is this node has 0 children. So to check that, I'm checking that left and right both are null. If yes, I will go inside these and I will create left child, okay, by tree node and the value should be 2 into c plus 1. Okay, just to just putting I'm random value, you can also place any value, that is fine. Okay, fine. So the same thing I will do for right 2. This is right child. Okay, and I will add random value, that is 2 into c plus 2. Okay, now what I'm going to do is, in this node, it has, if this node has 0 children, I will add these two newly generated children to its child. Left will be left child and right will be right child. Okay, so what we have done till now, we have got this node. Now we are trying to attach my newly created node in this node. Okay, so that logic only I have wrought here. I have created two node and I have added these two node in my particular node which has 0 child. Fine. Okay, now what I'm going to do is, I'm going to clone this tree. Okay, I'm going to clone this tree. So we have wrought a clone method. In this clone method, I'm going to pass this root. Okay, you remember, okay, let me tell you, we have discussed one thing, that why we are cloning. Okay, so we will be getting this result from n is equal to 5. In this tree only we are going to do changes every time. Okay, so I need root of this tree, so that in clone tree, if I pass this root, no, I can clone that tree, then only I can clone this tree. That's why I need the root of this tree. Fine. So that's what we are passing here, and I'm passing this root to the clone tree. Once a tree is cloned, it will return that root of that newly generated clone tree, and after that I will check, is tree similar or not. Okay, so what I'm going to do is, I will make one global variable, and I will name that as a, I can say that I will name that as a result list tree node. Okay, I will name that as a result new array list. Fine. Okay, I will make one boolean variable, that is tree same, and initially I will write false. Okay, and I will ask my is tree similar function to check in my list. Right, in my list I will be having some generated tree. Now I have cloned one tree, and I will check with all these existing tree which I have generated, that this newly generated tree is same for my existing tree or not. If it is same, I'm not going to add in my list. If it is not, then I will add that newly generated clone tree. Okay, clone, I can say full binary tree. Okay, so that's what I'm checking. So I need to check that is result size is greater than 0 or not. Okay, then only we can check. There should be some tree, existing tree in result, right, in my result list, then only I should check. So if it is there, then what I'm going to do is, I will iterate through all the nodes. I can tell existing tree node from result, and I will pass into is tree similar, is tree, what I name that is r tree similar. I will pass my existing node and the clone tree node. Okay, if somewhere I will get as is tree similar or same, if I get somewhere as true, then I don't need to check for rest of them. I will break there itself. Okay, I will break there itself, and I will check is tree similar is still false. If it is false, then I'm going to add in my result this clone tree root. Okay, fine. I hope you understand till here what we have done. Okay, once this will get finished, we'll come out of this else if and we'll call for playset. I will pass here root as it is and node dot left, and I will randomly assigning any value here c+1, or here I will be doing c+2, or here I will pass right. Fine. Okay, so what let's try to iterate over this. What we have done, if node is equal to null, we will return. Else what we are going to do is we will be checking if this node has 0 children. If yes, then we will be generating 2 child with uniquely assigned value, and we'll assign those 2 value in left and right child for this node. Okay, then we'll clone that tree, and once we have cloned, next thing we have to do is that we have to find out that is tree similar or not. This clone tree already exists in my list. If yes, then we don't need to add in false. Based on if tree is similar, it will return true, else it is going to return false. So is tree similar is false means we this tree doesn't exist in my list, so I will add in my result. Fine. Okay, now let's write another function, that is public, and this is going to return something like I can name that list of node. Okay, tree node. Fine, and I will name that all possible full binary tree. Okay, I will name that as full possible binary tree. Okay, so it is going to take n, that is number of nodes. Okay, now we know that what is the base case. Base case is for n is equal to 1, we have one full binary tree, that is node with 0 children, correct? So we'll add that in our result. Okay, result array. So I'm going to create one node, and I'm going to name that as a root, and new tree node. I will add value as 1. Fine. Now I will make here a list, and this will also contain tree node and current list. Okay, new array list. Fine. Now what we are going to do is, in my current list I will add this root value. Fine. So what we have done, we are maintaining 2 list, current list, and I have added my root 1. I will name that as a root 1. Okay, and currently the result list which is empty till now. Fine. Okay, now what we are going to do is we are going to iterate I is equal to 0, I is less not 0. We will going to start from 3 because already we have generated for 1, so we're going to start from 3, and we will be going to till n. Okay, and I plus plus. Fine. Now here what we are going to do is we are going to iterate through all the generated tree node which is in current list. Okay, so tree node, I will name that as a node, and current list. Fine, and I will call place it function. Fine, I will call place it function, and I will pass this node and this node, and I can say I can pass here as 1, simple value 1. Fine. Now we have called place it function. So now what is going to happen is it is going to generate all the result, and we are going to add in a this result variable. Okay, so what is going to happen is we from 1 we have generated this solution for n is equal to 3. We are going to add this root in my variable, that is result we have declared at the top. So I am going to add root of 3, this n is equal to 3. Okay, so when this one will get finished, this place it function has been executed. In result variable I will be having all the full binary tree has been generated for n plus 2. Okay, so what I'm going to do is here is I will make my new current list as new array list by passing result. Okay, and result I will make as empty. Okay, and I'm going to return result. Okay, fine. Okay, so before returning to there, let's try to print out all the result. Okay, let's try to print out. So we have already got display function, so I'm going to call that display tree. Okay, so for tree node n, and result will contain my all the possible full binary tree roots. Okay, so one by one I'm going to pass in a display tree method. Okay, and it is going to print. At last what I'm going to do is system.out.println just simple line. Okay, so loop. So it's going in infinite loop. Okay, so let me tell you what was the mistake we have done. Okay, so mistake was we have not did the backtracking step. Okay, so for n is equal to 5 we have this result. Now I want for 7, so I will add these two node here, then I will clone it. Okay, as we are doing changes in the same tree, what we need to do is whatever the changes we have done, we have to backtrack that, correct? So we have to again remove these two node, so in next iteration we will be able to add the two nodes here. Okay, so we need to do backtrack. That means we need to revert our solution once we have cloned that tree. Okay, so that was the thing we have missed. So I have added here, once I have cloned, now the particular node dot left equal to null and particular node right equal to null. Another thing what we have missed is, are tree similar? That we have done one mistake, that this check is for if both has been null, that means one of my part of both the tree has been same. Okay, now I need to check that if any of them got null and one of them is not null. Okay, so I'm checking if any one of them is null, that means I need to return false. That denotes that our tree are not similar. Okay, so these two mistake we have done. Now let's try to run this code. Okay, for n is equal to 7. So we got the result. Let's try to copy paste in some editor. Okay, so these are the result I got for n is equal to 7. Okay, so let's try to draw tree for one by one for all this generated binary tree. Okay, so we can rectify our answer. Okay, so these are the answer we got for n is equal to 7. Okay, so let's try to draw tree for each of them. One has left equal to 3 and 4. 3 has left is equal to 5 and 6, and other than that 5 has 7 and 8. Sorry, 8. So first tree we got as this. Now let's try to draw second tree. 1 has 3 4, fine. 3 has 5 6, okay, and 6 has 9 10. 6 has 9 10, fine. Now let's try to draw for this. 1 has 3 4, 3 has 5 6, okay, and 4 has 7 8. Okay, fine. Let's try to draw for this one. 1 has 3 4, okay, 4 has 7 8, okay, 7 8, and 7 has 9 10. 9 10, okay. 1 has 3 4 and 3 has null. 4 has 7 8, okay, then 7 has null. 8 has null, sorry, 8 has 11 12. Okay, so all the answer we got, that is correct. So let's try to deep down into our two function we have wrought, that is all possible full binarity and paste it. Let's try to understand that one iteration. Okay, one iteration, that is for n is equal to 5. Let's try to understand those two functions. So let's try to understand for how the code execution is working for n is equal to 5. Okay, so if you understand for n is equal to 5, you can iterate over n is equal to 7 also. So you can do that. We are going to do here for n is equal to 5. Okay, so I have made one list. I'm executing this line, so I have made one list that I will name that as a result. Okay, currently it is empty, fine. Okay, now we have called all possible full binarity by passing n, that is 5. Okay, now next what we are doing is, we have made one root, we have made one node, and I will name that as a root, and by passing the value as 1. Okay, I made one root. Now next is, I made another list, that is current list. Okay, current list, fine. And in that I have added this root which I have generated. Okay, so currently it has one node with value 1, fine. Okay, now I will iterate from n is equal to 3, because for I have already generated answer for n is equal to 1. So I will iterate from n is equal to 3. Okay, so in current list only one node is there, that is this one. So I will pass this node to place it. Okay, place it. Okay, now let's come to this. I have one node, that is this one. It is not null. Yes, it is not null. I will check, is left equal to null and right equal to null? Yes, it doesn't have left, it doesn't have right too. Correct. So I will make a new node with value, let's make a new node with value 2 into, see I have passed here, that is 1. So 2 into 1, that is 2. I made this node, and I will make right side, that is another node. 2 into 1, that is 2, plus 2, that is going to be 4. Fine. Okay, here we have made a mistake. I think 2 plus 1, that is going to be 3. So 3 4 we have made. Okay, okay, fine. So we have made a 2 node here. Now I will attach this 2 node in this node. Okay, in this node we have that we have passed. Okay, using these 2 line. Now I will call clone function. So it is going to return me the root. It will generate another tree with the same structure, and it is going to return me root for this. Okay, fine. I get clone root. Okay, now I will check, is this tree similar or not. So I made one variable, and before checking that, I will check, is in my result, size is greater than 0. What is my result size? It is 0, right? So we are not going inside this if. Okay, so because of that, is tree same going to be false. And now in my result I am going to add this clone tree root. Okay, so what I have as an answer is this tree I have. Okay, so I got answer for n is equal to 3 as of now. And now what I'm going to do is, this was my node. Okay, now I need to remove what the node which I have added here. Okay, so I need to remove these 2 node. Okay, fine. Now I will pass root dot left, that is null. Okay, that is null. And root dot right, that is also null. So it will come out of the place it. Okay, so we will be coming out here, and in my current list I will add all the result data. So result have, again still result have one data, and that is different tree, that is this one. Okay, previously it has this tree that has single node. Now it has node with tree which has 3 node. Okay, and I will make result data as clear. So now result will become again clear. Fine. Okay, now let's move to the last iteration, that is n is equal to, here I was 3, here I was 5. Okay, so in my current list, what are the nodes I have? That is 1 only. So I am going to pass that in a place set. Fine. So I came here in my root, this node is there, and in my node this node value is there. Okay, node is equal to null? No, it's not equal to null. Okay, in my node currently root is also pointing to this, and node is also pointing to this. So I will check, is left is equal to null and right is equal to null? No, right? Left has some value, right also has some value. Correct. So I will go, so this else if is not going to execute. So I will come to place set. Okay, in place set I will pass left. Okay, left value. So this node I have passed here. Okay, I will name that 1 2 3. So here came 2. Fine. Okay, c plus 1, that is 2. Okay, so 2 came. Now node is equal to null? No, right? But this condition is going to satisfy, that is left equal to null and right equal to null. Yes, correct, left and right both are null. So what I'm going to do is, again I'm going to create a 2 child by the value should be 2 and 2 into c. What is the value of c? That is 2. So 2 into 2 4 plus 1 5. So with 5, one node I have created. 2 into 2, that is 4 plus 2, that is 6. Another node I have created. Now in this node I will add this. Okay, 5 and 6. Fine. Okay, so I have passed this node, but this node is pointing to, actually this is a whole tree. I just passed this node, correct? So this is a whole tree. Now I will clone this whole tree. Okay, so it in my I will get root for this clone tree. I got this as a new full binary tree, and I will return root of this tree. Okay, now I will check is tree similar. Okay, but the result is still, result doesn't have any value, so we'll not going to go in this if. Okay, now I will add in my result one tree, that is this. Fine. Now in my node, this is my node, I will revert my changes. That means I will remove these changes. So again my tree is going to become something like this. Okay, now we'll going for the next iteration, that is node dot left. So I was here, now I will pass node that is null, so I will return from there. Okay, so it will return here, and I will pass node dot right. Okay, so node dot right has some value here, so it is not null, so we will going to else if. Okay, again I'm going to create a two nodes, and the value I have passed, that is previously it was 2, and 2 plus 1, that is 3, so we have passed here 3. Okay, fine. Now what is going to be happen here is, we will be creating two nodes with 2 plus 3, that is 6 plus 1 7, 2 plus 3, that is 6 plus 2 8. We have created this two node, and I will add that into my current node. Okay, so what was my current node? Sorry, let me have some space here. So this was my node, I have passed this right, and current node is 7. Sorry, newly created node is 7 and 8, so I've added here. Now what I'm going to do is, I will clone this. Okay, I will clone this, and I will return the root of this tree. Okay, so my result is going to contain two data, that is this one and another, that is this one. Okay, because before that this function is going to be this line is going to be executed, and we'll check that this tree is not similar to this when we are going to add into my result. Okay, now again in this line we'll backtrack, and whatever the changes we have done in this tree will revert that. So again my tree will become something like this. Okay, root dot left and root dot right, and those are null, so we will be going to return from this place set. Okay, so for n is equal to 5, okay, we got this in the result, and what we are doing is, we will be adding that into current result, this data. Okay, we have added, and I have made again this result as empty. Clear means it will clear all the data. Okay, so I have made result as empty. So for n is equal to 7, if we want to check, we will be reusing this data which has contained the current list. So current list has contained these two full binary tree, so we will be reusing that for generating all the result for n is equal to 7. And at last, in this case n is equal to 5, this will not going to execute anymore, and we are going to return a current list which contain these two result, or these two full binary tree. Okay, I hope you understand this solution and the for approach for this problem. Okay, so that's it for today. We'll meet in another exciting problem of recursion. Till then, take care. Bye bye.